Continuing the unit, Basic Chemistry, Part 2, Writing Chemical Formulas. The standards that we're meeting with this unit, and the unit essential question: how do chemical reactions help us examine the nature of matter? To start this lesson, start on page 86 with the quick write. Pause the video to answer these questions. What is the formula for water, for carbon dioxide, and for salt? The formula for water is H2O. The formula for carbon dioxide is CO2. And the formula for salt is NaCl. Turn to page 87 and set up your paper for Cornell note-taking. The essential question for this lesson is: how do you construct a chemical formula? Chemical formulas are also sometimes called molecular formulas, and they are a combination of chemical symbols and numbers to represent a substance. For example, H2O is the chemical formula for the substance water. Chemical symbols represent the elements in a molecule. The numbers represent how many atoms of each element make up the molecule. So pause the video to answer this question. H2O has blank atoms of hydrogen and has blank atoms of oxygen. Well, we know that H2O has 2 atoms of hydrogen and 1 atom of oxygen. But the question is why? Why isn't it H3O? Or why isn't it HO2? Well, let's find out where it comes from. To write a formula, you need to start with the ions that you want to bond. For example, we have hydrogen plus 1 and oxygen minus 2. We're going to cross the charges down to subscripts, so it looks like this. Okay, we'll bring the 2 down below the H and the 1 down below the O. To give us this, we have H2 and O1. So when we write that as a formula, it's going to look like this, H2O1. But we don't call it that. We simply call it H2O. So, chemical formulas, where do they come from? Pause the video to practice each of these problems. So we start here with sodium plus 1 and chlorine minus 1. We're going to cross the charges down to subscripts, and we get Na1Cl1. Now the fact that Na is here and Cl is here already tells us that there's 1. These little subscript ones are redundant, so we don't have to write them. We're not canceling them out. The fact that Na is here and that Cl is here says that there is 1. We're not canceling them out. These subscript ones are just extra. So we simply write the formula NaCl. Okay, looking at the next one. Magnesium plus 2, chlorine minus 1. We cross the charges down to subscripts, giving us the formula MgCl2. Okay, the next one. Aluminum plus 3, fluorine minus 1. We cross the charges down to subscripts, giving us the formula AlF3. And taking a look at this last one, we have copper plus 2, and we have a sulfate molecule that has a charge of minus 2. We still cross the subscripts. However, what are we going to end up with? Are we going to end up with Cu2, SO4, 2, equals simply CuSO4. Can we cancel these 2's? Or will we have Cu2 parentheses SO4 parentheses 2? Well, again, looking back here, we weren't canceling these 1's. These 1's were simply redundant because the Na and the Cl are here. Over on this problem, we must leave the 2's because it represents that there are 2 copper atoms in this molecule and that there are 2 sulfate molecules as part of this larger molecule. Now, looking at this, writing chemical formulas, you're going to be moving forward to balancing chemical equations. And to do that, you have to understand how many atoms are in each of these molecules. Pause the video to count the atoms in each molecule. Well, we have 1 Na and 1 Cl for a total of 2 atoms in that molecule. We have 1 magnesium, but we have 2 chlorines. So we have 3 atoms in this molecule. If you said that there were 4 atoms in this molecule, you were correct. We have 1 aluminum and 3 fluorines. Take a look at copper sulfate. We have 2 coppers. We have 2 sulfurs. And we have 8 oxygens. We must distribute this 2 over everything in the parentheses. Okay, you're going to continue working with chemical formulas on the practice page and then choose a choice product to complete this lesson.